Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll explain you complex series programs and other programs using nested for loops. Let's see the contents. Complex series, introduction, dry run of a factorial program, dry run of sum of series, Java programs based on nested for loops. Let's see the introduction. A set of related numbers or letters in some order or format is known as series. Complex series involve two or more loops. They require either nested loops or method calling. Method calling, which I'll teach you. N exclamation means factorial of a number. Factorial, which requires a loop. Now, what is factorial? If n is equal to 3, then n factorial is 1 multiplied by 2 multiplied by 3. Starting from 1 till the number, we multiply all numbers. Then the answer is 6. If n is 4, then n factorial would be 1 multiplied by 2 multiplied by 3 multiplied by 4, that is equal to 24. Let's see some of the programs which involve nested loops. Sum is equal to 1 upon 1 exclamation plus 2 upon 2 exclamation and so on. In this type of programs, addition is happening for each term, and the first term has factorial 1 exclamation, second term 2 exclamation, third term 3 exclamation. So calls for another loop, factorial. So outer loop adds, inner loop finds factorial and then does 1 upon that factorial. Second question, x square upon 1 exclamation plus. So there is addition also as well as factorial. Outer loop adds, inner loop finds factorial for the term. So this is how we decide. Then 1 plus 2 upon 1 multiplied by 2. This is the first term. Second term 1 plus 2 plus 3 upon factorial of 3. So here for addition of the terms we have outer for loop and two individual loops. One is adding the part of a term upon factorial of that particular subterm. And then last question is read a range from user and display all the palindrome numbers in the range. Palindrome program I've taught you in while loop, which requires a loop. So range is given. We have to find out, let's say range is 10 to 50. Take the number 10, decide palindrome or not. If palindrome display, then 11, then 12. So outer for loop takes the range and gives numbers to the palindrome part. So all these programs can be done either using nested loops or method calling. Dry run of a factorial program, simple program for loop. Display factorial of a number. Let's assume user input is 4. See the code. Read n, which is 4. We are taking accumulator variable fact. Int fact is equal to 1. Why? Because any number multiplied by 0 would be 0. So accumulator variable we take 1. And a counter variable is there. Int I equals to 1, I less than equal to n, I plus plus. 4 times this loop works. fact into equals to I. This is shorthand operator. So fact is equal to fact into I, whatever is there in I. Let's see the dry run. N would be 4 for all the iterations. I works 4 times properly and then 5th time false. Let's see the fact is equal to 1 column. Initially fact has 1. Fact into I should multiply and then store in fact. Fact is equal to fact multiplied by I. In that case, I is 1, fact is 1, 1 multiplied by 1 is 1. In the second iteration, I is 2, fact is 1, 1 multiplied by 2 is 2. In the third iteration, fact is 2, I is 3, so 2 multiplied by 3 is 6. Fact is 6 and 4 in the fourth iteration. 6 4s are 24. This is the desired output. Now the same program we want to use in sum of series. The question is display sum of series 1 upon 1 exclamation plus 2 upon 2 exclamation. See, if you observe, 1 exclamation 1 into 1, 2 exclamation 1 into 2. So every time in order to find the factorial, I need the accumulator variable as 1. But for sum, we need to sum up all the terms. So sum variable is declared outside the for loop, that is outer for loop. This is one accumulator, sum is 0. Implicit conversion, although we have given 0, double is there, so 0.0 would be stored by the Java compiler. Then one outer for loop and one inner for loop. Inner for loop in red color, int fact is equal to 1 reinitializing for each iteration of outer loop. And then this program we know, but there is one small change. Int j is 1, j less than equal to I, because if I is 1, first term, only we want to do 1 multiplied by 1. In the second term, we want to do 1 multiplied by 2. So it depends on I. So j less than equal to I, j plus plus, fact into equals to j. Then sum up. Somehow I upon, I is 1, upon factorial of I, that is 1. In the second case, double I, that is 2.0, this is explicit conversion, upon factorial of 2. And at the end, after all the for loops, we display the sum. See the dry run. I is 1, 2, 3 true, 4th time false. Now fact is reinitialized for each iteration of I. When I is 1, fact is 1. I is 2, fact is 1. I is 3, fact is 1. Now jth loop works how many times? I many times. So when I is 1, j works only 1 time. When I is 2, j works twice. 3, thrice. Let's see the fact is equal to 1, fact into j column. First time 1 into 1 is 1. Final answer is 1. Second time 1 into 1 is 1. 1 multiplied by 2 is 2. Answer is 2 in that particular iteration. When I is 3, 1 multiplied by 1 is 1, 1 multiplied by 2 is 2, then 2 multiplied by 3 is 6. So the sum variable is initially 0.0 using double of I, that is red colored I1, upon factorial factorial for that particular iteration is 1. So 1.0 upon 1 is equal to 1.0. Then second iteration 2.0, that is I, upon the factorial of 2 is 2 is 1. So 1.0, the previous sum, plus 1.0, which becomes 2.0. In the third iteration, sum is equal to double I, that is 3.0, upon factorial of 3 is 6. So 0.5. So initial 2.0 plus 0.5, answer would be 2.5. Let's see a Java program. Let's see factorial program. See, n is read, int fact is equal to 1, for int j is equal to 1, j less than equal to n, j plus plus, fact int 2 equals to j, and print the factorial. If n is 3, output should be 6. So let's execute void main, okay, and it is asking enter a number. Let's say 3, and then enter, factorial is 6. Fine. Then fact series. We are reading n, double sum equals to 0. The question is the very first question which we have discussed, 1 upon 1 exclamation plus 2 upon 2 exclamation, and so on and so forth. So for that we have taken outer for loop 1 to n, but 1 upon 1 exclamation. So we need the factorial program. So let's copy this part and Control C. Here we need one change. What is that change? Our loop should work I many times. Here it should be j less than equal to I. So in the first iteration, 1 time it works. Second iteration, 2 times. And sum should be double I upon the factorial. So if we see, if we give the input 3, output would be 2.5. 1 upon 1 exclamation, that is 1 upon 1 into 1. Sum would be double of I, that is 1.0 upon 1, 1 upon 1 is 1. Then answer would be 1.0. 2 upon 2 exclamation, 2 upon 2, that is equal to 1.0. 3 upon 3 exclamation, that is 3 upon 6, that is equal to 0.5. So add 1.0 plus 1.0 plus 0.5 is 2.5. So if input is 3, then output should be 2.5. Compile and then execute. Enter n, 3, output is 2.5. Let's see sum of series program. Here the question is x square upon 1 exclamation, x cube upon 2 exclamation. Same similar program. N and x are accepted. N and x, sum is 0. I 1 to n, the good old factorial program. J is 1, j less than equal to I, j plus plus fact into j. In the sum part, we take x, x square. So I is 1, we are using the I. Sometimes we cannot use the same outer loop variable. We'll see that kind of program also. X, math.pow returns the raised to the power of base and exponent. Base is x. exponent is I plus 1. That is temporarily. When I is 1, it becomes 2 x square. When I is 2, it becomes 3 x cube. So, first subterm is math.pow x comma I plus 1. Base and exponent separated by then comma, then upon factorial. So when we execute this program, if we give n is 3, x is 2, output is 10.6666. So x square is 4 because 2, 4 upon factorial of 1 is 1, that is 4.0. X cube is 8 upon 2 factorial of 2, 4.0. X raised to the power of 4 and so on. Let's execute some series program. Compile and then void main. Okay. Enter n 3 x 2 10 point the answer. Now let's see the sum product program. Here 1 plus 2 upon 1 multiplied by 2, this concept. We need one outer loop, we have already decided that, and two individual, one for factorial, individual loops, factorial, another for sum. And if you see 1 plus 2, so in order to run the loops 1 to 2, we have started the I, that is counter variable, with 2 less than equal to n. Then this is factorial part, int fact is equal to 1, this part, and another loop, sum of individual subterms, j is 1, j less than equal to I, j plus plus, sum plus equals to j. Here the accumulator s variable has 0 because it is sum. Here accumulator variable fact is 1 because we are doing multiplication here. Now total sum, tot sum is a variable which is taking double of sum upon factorial and then printing total sum. The answer would be, if the input is 4, 1 plus 2, whatever, this is 3 upon 2 is 1.5. This one 6 upon 6 is 1.0. This one 10 upon 24 is this answer. So final answer would be 2.9166665. We can format this using printf statement. System.out. Not println, printf, just like C. Formatted output, here we need to specify percentage comma inside the double quotes. Percentage comma, point how many digits you want, 2f, 4f, 3f, whatever, formatted. So total sum will be formatted to 4 digits of precision. If you see, this big answer will be formatted. So first we are printing the original answer, then formatting. So Control K and execute sum product program. Sum product main. Okay. Enter n. We have decided 3, 2.50. Let's assume the previous one which I wanted to show you, 4, n is 4. N is 4. Answer is 2.911. Formatted output till 4 digits is 9167, rounding off. Then when we are dealing with loops, our output may go wrong and infinite loop, it may go into infinite loop. In that case, how to come out of it? Look at this. I have deliberately used for loop, this which is infinite loop, no condition. Unless I give a break, this particular loop keeps on working. If we execute, it keeps on working till we stop manually. See, infinite loop, it keeps on working, this candy. So how to do stop it is reset Java virtual machine, then only it is stopped. Now palindrome, this program I have explained in while loop. First of all, we are reading in, we are reversing, but when we reverse, this n becomes 0. Reverse cannot be compared with n, so we have stored in num while n greater than 0, d is equal to n modulo 10. Please visit that while loop video. Rev is equal to rev into 10 plus d, n upon equals to 10. If number is equal to reverse, that number is palindrome. If we enter, let's say 11, enter number 11. 11 is a palindrome. If we enter some 15, is a not palindrome. Fine. This program is working. The same program we use in range. Read a range and display palindrome numbers. So A, B we have read. I is equal to A, I less than equal to B, I plus plus. Let's assume A is 10, B is 100. This for loop works 90 times. Actually 91 times. 10 also included. Now outer for loop is giving a number one by one, one by one, one by one. 10. Similar to the previous program, int n is equal to I, that is number. Int num is equal to I. This is very important. We cannot take I as a part of this while loop, because this while loop, whatever number we give, makes it 0. So, loop control variable should be different from this particular inside program. So, n we are giving, which is I, and num is equal to I, int reverse is equal to 0. Here we can take I because we are not touching num is equal to I, not required. Okay, this program works, and we are saying if number is equal to reverse, then print that number. No need of printing not a palindrome, yes palindrome. So inside loop, inside the loop. But these nested loops can be written as method calling. This is a little tricky. So method calling, importance of method calling we are highlighting because nested loops will be little difficult. But let's execute this program and see. Enter range 10 to let's say 100. All the palindromic numbers are displayed. Okay, let's go back to our PowerPoint presentation. I have given links to implicit, explicit conversion, counters and accumulators, while loop, operators, variables videos in the description box. Refer Chapter 9 of Basics in Computer Applications for further understanding and practice exercises. The next video is about square, rectangle, triangle patterns using nested for loops. Thank you.